All right, good morning. I just wanted to check in with you guys on what you're going to be working on today. So yesterday we looked at finding areas of squares, rectangles, parallelograms, and triangles. Today is going to be totally focused on triangles. And as you'll find out later this chapter, just like you've seen throughout the entire year, being able to work with triangles is crucial to your success. So the reason that we're looking at triangles specifically today, even though the area formula is not that difficult, 1/2 the base times the height, oftentimes we're going to run into situations where we don't know the base or we don't know the height of the triangle. So what do we do about that? Well, you can see over here on the screen the things that we have to remember: the Pythagorean theorem, including Pythagorean triples, 45, 45, 90s, 30, 60, 90s, or using sine, cosine, or tangent to help us find that missing side length. When we get into finding areas of regular polygons, okay, shapes, regular octagons, regular pentagons, those kind of objects, being able to find the area of a triangle is really important to finding the area of the entire object. We talked yesterday about our learning target, being able to decompose a shape down into smaller shapes that we can find the area of. Oftentimes those smaller shapes are triangles. So as you guys will see with your practice, there we go. I have given you several triangles here, okay? And you need to find the area of each of these triangles. Now the way that I want you to do this is I want you to find the exact area, and once you've found the exact area totally simplified, then I want you to round. Don't round from the end. Sometimes students want to just plug into the formula and then type the whole thing in your calculator and then get your answer. Well, when we're decomposing objects into triangles, okay, we've talked about it so many times, don't round until the end. Okay, so we're going to want to find the exact area. The only reason I'm having you round right now is just to get used to rounding again to the nearest tenth and being able to check your answer in that way. So I'm just going to do one or two problems here, just reminding you on what's happening here with these different objects, different techniques for finding side lengths. So let me just sketch up a right triangle. Okay. And I just want to talk about what method would you use. So let's say I wanted to find the area of this triangle, and I knew this was 30 degrees, and I knew that was 10. Okay. I want to find the area. Well, the area formula, 1/2 base times height. Well, I'm missing one of the dimensions that I need. If I think about this as my height, this would be my base. How am I going to solve for this? What information do I have? Well, can I use the Pythagorean theorem? No, I need to know two side lengths to use the Pythagorean theorem. Okay. Is it a 45, 45, 90? Nope. Is it a 30, 60, 90? Yes, it is. I could also use SOHCAHTOA, but I know 30, 60, 90s are a lot faster than that. Okay, remembering my pattern here, this is 10, this is 20, this is 10 root 3. So, area formula, 1/2 the base, 10 root 3, times the height, 10. Now let me show you what I mean by simplifying and giving my exact answer. I am not going to type that in my calculator yet. I'm going to take, let's see here, I'm just going to leave that root 3 alone. I'm just going to pretend that's not even there. 1/2 times 10 times 10. Well, 10 times 10 is 100. Half of 100 is 50. The exact area of this triangle is 50 root 3. That's what I need you guys to be able to do. Once I have that, I'll just grab out my calculator. 50 root 3, 86.6. Square units. All right, let's look at one other. Let's go 10 here. Let's go 4 there. This is my right triangle. Well, I'm missing the height on this one. How am I going to find that height? I don't know it's a 45, 45, 90. I don't know it's a 30, 60, 90. I don't have an acute angle to use SOHCAHTOA. This is a Pythagorean situation here. So let me just call this h for height. I've got 4 squared plus h squared equals 10 squared. That's 16. That's 100. Okay. H squared is 84. Okay. Now, I'm going to take the square root, and I want to simplify this. I just made up these numbers, so I'm going to have to grab my calculator and try to find that biggest perfect square that evenly goes into 84. So let me try. Does 4 go into 84? Yeah, it does 21 times. Okay. But I'm going to try a few bigger numbers. I know 9 doesn't. Does 16 go into 84? No, it doesn't. I know 25 doesn't. 36 doesn't. I think 4 is the biggest one. So our height here, this is the square root of 4 times the square root of 21. That's 2 root 21. Okay. So I'm going to come over here and find my area now by taking 1/2 the base, and the height is 2 root 21. Okay. Now simplify. Just ignore that square root for right now. 1/2 times 4 is 2. 2 times 2 is 4. The exact area of this triangle is 4 root 21. That's what I type in my calculator and approximate to the nearest tenth. 18.3 square units. So as you guys work today, okay, take a look. What's the situation? What do you know? How are you going to go about solving it? Okay, do your best today. This is really important stuff. Right, thank you. See you later.